Hi everyone, this is Billy. In this video, I want to show you how I design and build this antique-like portable AM shortwave FM radio for crystal radio that allows you to listen to radio without battery. If you have a strong signal, you can drive the small speakers there too. I've been trying to improve my videos by adding subtitles, closed captions, so please turn that on if you want to see what I'm saying. It's also translated into different languages, simplified Chinese and traditional Chinese. If you like my video, please share, click like, subscribe. Thank you. In the last video, we looked at how to create this bigger antique-like crystal radio that can drive a speaker for AM, FM, and shortwave. Today, I will try to miniaturize this setup to a tiny plastic box that can have the same function of crystal radio listening to AM, shortwave, and FM broadcast stations. So this is a portable AM, shortwave, and FM crystal radio. It is divided into three parts: the FM, shortwave, and the AM. And each part is its own resonance circuit. Let's talk about the FM first. We have a very small variable capacitor. It's the plastic variable capacitor that you can find in the market for many portable small radios. It is a very small unit with 4 gains. The first 2 gains is for FM. It's a small variable capacitor from 5 to 22 PF. We use one of the first gain to add into this FM crystal radio. The coil is made of a 2 mm thick copper wire that is wound on top of an AAA AAA battery. So you wind 5 turns, take a tap on the first turn and the second turn, and connect it according to this circuit diagram. First turn is the signal ground. Second turn is connecting to your diode, or in this case the 3DQ's S pole, or it also connects to your antenna. Your other antenna can be a drop cable connecting to one turn after ground. If you are using a Yagi antenna, you can connect the terminal shown in here to your 2 terminals in the Yagi antenna. For filtering, we have a 100 PF capacitor to filter out all the high frequency and leave only the audio frequency to pass through. And then we have a switch to select which part of the radio gets the output to the headphone and speaker. This is a meter. It's a DC current meter of 50 microampere. This one is bidirectional. That means you can start from negative 50 microampere to positive 50 microampere with the center point of 0. The reason why we need to use bidirectional meter is because the 3DQ, unlike the dial, it do not always control current flow in a single direction only. It can go back to a second direction. It's like more a vacuum tube. It functions actually like a vacuum tube, this most FET. So depending on the phasing of the channel you tune to, compare with the rest of the circuit, it may actually flip the current flow in any direction, depending on which station you tune to. More noticeable in the shortwave area than the MW and the FM area. Okay, so instead of flipping your switch to change the current flow, it's better to use a bidirectional meter. Okay, the other thing you need to notice is this: there's a 10 microfarad capacitor connected in parallel to this meter. It will allow the audio signal to pass through, so it won't deteriorate the volume of the headphone or your speaker by connecting in this current meter, which is an inherent resistance of around 700 ohm. The switch and the resistor down here, it is for extending your current meter to 10 times its value. For example, if you have 50 microampere, by connecting this one and flipping this switch, you can extend that to 500 microampere. So this is helpful if you have a strong signal and you want to measure higher output. You need to calibrate the meter first by changing this variable resistor. With the help of a multimeter, you can calibrate this resistor to either 5 times, 10 times, or even 100 times of the original value of this meter. There's a video when I show you the antique radio. I have a short video how you can calibrate. So now we come to the output. Initially, I want to use the transformer, a step-down impedance matching transformer, to match the 2K output impedance of my 3DQ with the 500 ohm output impedance of my headphone. But I find this transformer called ST32 a bit too weak. It actually deteriorates the output volume than helping. So at the end, I connected this headphone directly to the meter. But still, for the 8 ohm speaker, you will need to still use the transformer because the impedance difference is too much, 2K and 8 ohm. So you need to still use this ST32 or an equivalent or much better step-down transformer with this impedance matching ratio to connect to your speaker. For the headphone jack, we choose one with a micro switch. When you plug in the headphone jack, the speaker will be disconnected. When you unplug, the speaker will be connected so you can hear the radio. Performance of the speaker will be not very good, but it's just an experiment. If you have a very strong signal, like around 200 microampere of signal, then you can drive the speaker, and you can drive it quite loud. You can hear it 1 feet away. But if you have a weak signal, less than 10 microampere, you may still be able to drive the speaker, but you need to press it against your ear to hear it. For the shortwave circuit, we use a 31mm ferrite core, which is also R4TC1, high Q factor core. You use a 1mm copper wire to wind 8 turns. If you have silver plated copper wire, it's even better because that has a lower resistance to high frequency. And you tap at the second turn, and that will become your signal ground. Okay, for AM, you use also one of the gains of the variable capacitor. It's a 4-gain variable capacitor. We use 1 gain for FM, another gain for shortwave, and the third one will be used for AM. So it's from 20 PF to 350 PF. For the coil, we use the R4TC1 ferrite core, but it's a bigger one, 37mm in diameter and 15mm in height. And you wind 65 turns. You tap on the 5th turn, which will be your signal ground. So all these are connected through these 2 switches for medium wave and short wave to your 3DQ. I've tested the Q changes. Each switch you add to your circuit will deteriorate your Q. The only important thing is within your resonance circuit, you should avoid using the switch. You should always direct connect your coil and your variable capacitor together, direct soldering. So this part, if you use a switch, it will impact your Q and the performance of your radio very much. But in this part, it will still have an impact, but it may not be noticeable. So that's why I use the switch at this part instead of this part. Okay, and you connect to the S pole, which is like an input of your 3DQ. The G2, another input, you connect to the hot end of your coil. G1 we connect to the signal ground, and the D we connect to the output. For output, we use a 47,000 PF capacitor to filter out the high frequency and leave the audio signal. So this is a switch where you select whether you get the output from the FM area or from the medium wave and shortwave area. Okay, so for antenna we use the 1.2 meter telescopic extendable radio antenna when we use it outside. This part we can't use a switch, because if you use a switch to connect your antenna to your circuit, it will impact your radio performance a lot. So instead I put in multiple terminals in terms of an M4 screw, one for FM, one for medium wave. Then we can connect that by screwing the telescopic antenna directly onto those screws when you need to change to a different band. That will be more direct, and you can get a higher Q output. Or if you want to connect to a long antenna, you connect down in here, this other terminal, also connecting through another M4 screw. You can connect to your long antenna from your house. The longer the better, at least 10 meter. For the ground, is required only for shortwave and medium wave. For the ground, you can connect to your water pipe that connect ultimately into the earth. For FM, the antenna is a bit different. For FM, you can connect your 1.2 meter telescopic antenna there. If you want to have much better performance, maybe sometimes double the performance, you can connect another drop cable, a very thick cable. I use the copper shielding of another cable that will be better. So 0.8 meter down, 0.8 meter up. If you connect your Yagi antenna, you connect one terminal here, another terminal here. You need to use the parallel cable instead of coaxial cable. Otherwise, you need to have a baron to do the conversion. You are looking at the resonance frequency calculator. This is the Excel spreadsheet that I created with some formulas like this. So we can calculate from the inductance and the variable capacitors minimum and maximum value, result in the frequency range that you can tune to for any LC circuit. I have put a link in my blog, so you can download that file from my GitHub repository. So let me walk through what we have. For the AM band, we have an R40C1 core, and we made a coil of 200 microhenry. Minimum capacitance of the variable capacitor is 20 to 350. Straight capacitance is the thread or the wiring and spaces between the components. They will create another hidden capacitance that we use 5 to estimate. When you turn the variable capacitor all the way to the left hand side, you will have the minimum frequency of 534 kilohertz. When you turn it all the way to the right, you have the highest frequency of around 2000 kilohertz. And in the middle, when you turn it into middle, it's around 730 kilohertz. For shortwave, we have a smaller coil of 6 turns, and it's 3 microhenry. Minimum to maximum capacitance is the same because we're using the same variable capacitor but a different gang. Straight capacitance is similar, 5. The minimum frequency is 4.9 megahertz. Maximum is 18 megahertz. Middle ground is 6 megahertz. For FM, we are using a very small coil made of a few turns of wire over an AAA size battery. The coil is around 0.3 microhenry. Minimum capacitance is using the other gang of the 4-gang variable capacitor. It has 2 PF to 25 PF. For straight capacitance, we estimate at 1 PF because we try to keep the threads short within the resonance circuit. The coil is soldered directly onto the variable capacitor's terminal, no extra thread, so straight capacitance is much smaller, around 1 PF. Minimum frequency is around 57 megahertz, maximum 167 megahertz. It's actually a bit higher than the 120 megahertz required for FM range. In that case, you can also listen to some aviation channels if you are allowed to do that in your country, which is usually around 129 megahertz. We have the middle range, 76 megahertz. So this is my crystal radio. I printed a 3D printed back to cover it. This is the tuning. This scale is printed using the PowerPoint. I will put in the PowerPoint file so you can download. This is a positive and minus 50 microampere meter. This is a 1 watt speaker, so you can switch to FM, shortwave, and medium wave. These are the different antenna terminals. This one is for AM, this one is for FM. This is the second terminal for the FM antenna. So these two you can connect to the Yagi antenna, or you can connect a telescopic radio antenna here, and then a drop cable of 0.8 meter here. Okay, this is the antenna for MW and shortwave for the long antenna. This is the ground for the MW and shortwave circuit. This is the telescopic antenna for the MW and shortwave circuit. So to mount the antenna, you can screw it in like that. It's an M4 screw, and then you can extend your antenna. This antenna is 1.2 meter. There are antenna that is 1.8 meter as well, so you can buy the longer if you can. The longer the antenna, the better the reception for MW and shortwave. For FM, the antenna 1.2 meter is enough, because you only need 0.8 meter for the top one, and then another drop cable of 0.8 meter that drop down to form the dipole. Okay, let me show you the inside. So on the inside, you have two coils. This is the MW coil. Total 8 turns. You connect the second turn to the ground. This one is the MW coil or AM coil. Total 65 turns. You connect the 5th turn to ground, and then one end to the S pole of 3DQ. The 5 turn here. And then the rest of the 60 turns you connect to the G2 pole of the 3DQ, and also to the tuning capacitor. Okay, these are the 3DQ. I use a 4-pin socket to mount it, so I can replace it anytime. Sometimes the 3DQ will be damaged by a sudden high static voltage, which can come from a lighting or come from suddenly too high the radio signal. So sometimes you need to replace it. This is the variable capacitor. It has 4 gains. The first 2 gains is for FM. Capacitor range is from 2 PF to 25 PF, and then the 2 gain here is for shortwave and medium wave. Capacitance is around 20 PF to 350 PF. This is the band switch. So it is 4 terminals that you can switch with 3 options. So I use them to connect, to switch to FM, shortwave, and MW. We actually only needed 3 terminals for the switch, but you can't buy those with 3 terminals. So I bought this one with 4 terminals, and each terminal you can have 3 selection. Okay, so this is this very small transformer called ST32. So it has 3 terminals on one end. Each terminal is 6. The The primary stage is 600 ohm impedance. The secondary stage is 8 ohm impedance. So on the primary stage, you have two coils each of 600 ohm impedance. So you can use it to convert from the 2K output impedance of the 3DQ to your headphone, which is around 600 ohm, or from the 2K output of 3DQ to the speaker, which is 8 ohm. So you can use the secondary stage to connect to the speaker. Okay, to allow auto switching between headphone and speaker, you can use this type of headphone jack. If the headphone is plugged in, like this headphone, if it's plugged in, these two terminals will be disconnected, so the speaker will be disconnected. When it's unplugged, the terminal will be connected, so the speaker will get connected to the radio. Okay, so when we mount this coil, we better use this foam to secure it in place. And here as well. Okay, I forgot to tell you, this FM coil is 2mm copper wire. We wind it on an AAA cell, AAA cell as the frame, and then we get rid of the cell. Then you additionally wind one more turn to connect to the terminal for the FM antenna. Okay. So this core I'm using is R40C1, very high Q core. You need that for the shortwave. Also for the MW, you can use conventional core, but if you can buy the R40C1, you can also use this one. This will increase your Q by 1 time, double your Q. However, it depends on the reception. Sometimes it will only give you marginal improvement in the actual reception. So whether it's worth it, you have to test it to find out. It's not saying that the high Q coil will be definitely better, but it's give you some psychological comfort if you know you're having a high Q coil. I use this type of small meter. This one is a value of 500 microampere, but a while ago I was able to buy this very small tiny meters, which is only 50 microampere, but that shop is already shut down. So I still have one of these very small meter, so I can make this radio using this meter. See, it's very small here. The other thing I did is the original meter's needle is pointing here. It's not pointing at the middle. I open it up and I change the springs, turn it around so the needle points at the middle. That way it will turn into the positive minus meter instead of a single direction. Because the 3DQ is not like a diode. Sometimes, depending on the phase of your signal compared to your output, the meter will sometimes go this way, sometimes go that way, depending on which frequency you tune to or how you connect the antennas. So it's quite interesting. So for 3DQ, you can't use this type of meter. If you use this type of meter, you need to have another switch to change the direction of the terminals, which is quite troublesome. So I prefer to change the needle, readjust it to point at the center, and then I will reprint the scale, the dial scale for the meter, so that I can get positive and minus values. This is the regular sized current meter. This one is bidirectional, minus 25 microampere to plus 25 microampere. And the model number of the size is called 85C1. So if you purchase 85C1, it will be this size. It will not fit in my original case, but I'm going to create a 3D printed case that we can fit this in, and maybe you can also follow and create your own crystal radio. I use this type of very tiny plastic box as the chassis for my radio. I drew a lot of holes matching the components, and then use this furniture label sticker to decorate it. I understand that not everyone can use this tiny material, so in my next project I'm going to design this 3D printed chassis that you can use to make a little bit bigger radio that will fit many of the available components from the market. I'm testing the printing and how it works now. So once I figure out that it's workable, I'll upload and share the 3D model print files. Let's start the testing. All my testing recording for the crystal radio testing are done using this iPhone recorder transformer. So what it is, it's just a transformer to do DC isolation, and then there's a step-down transformer for headphone for monitoring. You can see there's no battery, no circuitry for amplification. So it's purely direct output from the crystal radio, and we hook up through this jack to the iPhone's recording terminal. So this is how I record. Just plug this in and then I can record. Okay. The other end I will plug into the crystal radio's output like this one. Okay, and then there is a monitoring port here. I will plug into my crystal earphone for monitoring. So this is how I record this testing video. I can post the link to this iPhone record transformer and show you how to make it. Testing in-house with the Yagi antenna for the FM radio. Testing in-house with the telescopic antenna for the FM radio.
第96号主席令。近住林士街嗰邊車多繁忙㗎，龍尾排到去近大地堂。喺九龍啦，太子地西天橋旺角方向近九龍城迴旋處嗰段橋面多車，龍尾去到太子道東近住港灣。阿基路街去九龍苑，龍尾喺荃灣排到星河名灣，反方向去觀塘排到天馬苑，觀塘道去龍翔道排到啟業村，觀塘繞道去油塘就喺九龍灣國際展貿中心，太子道東去旺角排到彩虹道，反方向去觀塘排到九龍城迴旋處，再入埋新界區睇睇，大埔公路入三條村。
Testing in-house with the long antenna for the medium wave AM radio.
I can't forget you.
Now I'm testing on the street with a telescopic radio antenna for the MW radio.
Tayo'y pinagtatakbo muli, inulit nagkasakita.
Now let's test the shortwave in-house with the long antenna.
ដើម្បីពង្រឹងខ្លួនឯងលោកលើកឡើងតាមសារអ៊ីមែលមួយថាបាទមានការព្រួយបារម្ភជាច្រើនស្ថានភាពកម្ពុជាបច្ចុប្បន្ននេះគ្មានការអត់ឱនទេ
我就聽過一個有啲毛骨悚然嘅故仔，就話有一個藝術學院嘅女仔3點幾上到5點啦，咁佢嗰日咧就有事就遲咗，咁已經遲到㗎啦，咁佢走到去嗰度 lift 嗰度，因為佢上就撳 lift 啦，喺度等啦，係咪？
Next, we are going to test the shortwave on the streets.
我们愿意借这个节目，将主赐给我们的这个恩典、这个真理，能够带给每一个人。所以盼望我们呢，能够在主的里面一同来享受主的恩典。最后呢，我们看一节经文，引致了罗马书8章28到30节。
我们知道，为了爱真主的人，就是按他旨意被招的人的益处，万事都一起效力，因为真主预先知道的人，他就预先命定他们和他儿子的形象一模一样，使他的儿子在许多弟兄中做长子。他预先命定的人，又召唤他们所招来的人，又称他们为义；所称为义的人，又使他们得荣耀。
Lastly, we are going to test the speaker with a long antenna. Still the speaker's output is not that high, so we have to put the mic quite close to hear it. That's the end of the video. Thanks a lot for watching. Thank you.